I'm Fred Lauzus, Senior Application Engineer with Spatial Integrated Systems. Today I'm going to present an overview of some of the enhancements and new functionality in Siemens NX10 for design, simulation, and manufacturing. First, some enhancements in NX Design. This includes enhancements in layout, realized shape, the user interface, and various areas of part modeling. Concept design is easier than ever in NX10 with NX Layout. NX Layout lets you explore design concepts in 2D for situations in which it's faster and easier to represent design problems. As you'd expect, NX Layout is fully integrated into NX and NX Drafting. This means there's virtually no learning curve because the interface and commands are the same. It also means that the 2D components you create in NX Layout are organized in the Part Navigator, and they are parametric, editable, and reusable. You can drag and drop 2D components from the reuse library to ensure quality and save time. Finally, anything you create in NX Layout can easily be migrated to 3D to complete your model. The 2D components come into 3D as constrained parametric sketches that can easily be modified. So when you finish your design in 2D, you're already well on your way to a complete 3D model. NX Realized Shape is an exciting concept design method that uses advanced subdivision shape creation, first introduced in NX9. It is intuitive, and you can create a shape based on a cage that can be extruded, swept, lofted, revolved, copied, and more. The cage faces can be created from curves or polylines and subdivided as much as you want to give you greater control with smooth transitions. The end product is high-quality B surfaces with an editable NX feature. This allows for rapid conceptualization of ideas without the need for expert knowledge. NX Realized Shape can be used in combination with or alongside other surfacing and design tools. In NX10, every aspect of NX Realized Shape has been enhanced to give you more control over your geometry. NX Realized Shape in NX10 is a complete set of tools for subdivision modeling. When you consider the advantage of full integration with NX, it's the obvious choice for creating complex models quickly and easily. Touchscreen support has been added to NX10. Touchscreens can be a quicker, more intuitive way to interact with software. In NX10, the power of NX is available anywhere thanks to the new optional touch-enabled interface. With NX Touch, you have the ability to access the full design capability of NX wherever you are, whether it's on the plant floor, while traveling, or just consulting with someone down the hall. Not only does it make it easier to have the information you need wherever you are, it makes you more productive and versatile. In touch mode, the interface adjusts to make it easier to select items on the touchscreen. The interface is remarkably intuitive and familiar to anyone who has used a mobile device and NX separately. For instance, to zoom, you pinch your fingers together, to select something, you tap it, and so on. Given the wide proliferation of touchscreen mobile devices, the average user will be up and running on NX with touch in just a few minutes. NX10 has many enhancements to the user interface. There are more supported options for using dual monitors, such as allowing overlap. Options are also available for the user interface's preferences. Ribbon bar improvements, such as a search field for the customized dialog to search for commands, groups, galleries, etc. New text styles, including medium, extra large, and all added. All sizes have a no text option. User interface preferences has been redesigned. It now uses a standard preferences dialog. NX10 is a complete, fully capable aerospace design solution. Commands for creating flanges, ribs, shelves, and steps were specifically developed for airframe and aeroskin designs, and they dramatically simplify and accelerate the aerospace design process. There are 2D synchronous enhancements such as T-junction support, point and curve constraints, offset constraints, maintain length option, fixed center option, chamfer constraint, and resize chamfer. Synchronous blend enhancements include notch and cliff blends can be deleted, and walls consumed by blends are recreated. The synchronous replace face blends enhancements include replace face with datum plane, improve multi-face replace, and improve tangent face replace. Optimized 2D geometry is a new function in NX10 that cleans up 2D data the way optimized face cleans up 3D data. It gets rid of junk data such as duplicate lines, extra points, tiny pieces of geometry, and other extraneous bits that make sketches difficult to use and modify. It can also planarize or move the geometry onto one plane. This is especially useful when working with 2D data migrated from another computer-aided design system. It's one of the many ways that NX enables you to reduce rework and part cleanup time. Model diagnosis can be a time-consuming task when modifying parametric models. The Face Snapshot command in NX10 is a powerful tool that saves time by showing you the previous state of any face. This makes it much easier to see any problem areas and fix them. Face Snapshot can display the previous state of failed or missing faces during edit. This functionality is consistent with Edge Snapshot and will save time fixing failed or missing inputs and features. Patterning has been enhanced to give you greater control and improve performance and efficiency. Also, creating high-quality blends with more consistent results is easier in NX10 thanks to tools such as Edge Blend and Face Blend. These new blend options let you control every aspect of your blend's geometry and create blends with G2 continuity for finished quality surfaces used in styling and industrial design. Creating high-quality surfaces in complex regions is easier than ever. Fill Surface enables you to create a surface by picking curves around its boundary with full control over continuity. Curves can now be wrapped or unwrapped across multiple faces. Not only does this increase versatility, it's especially helpful for making use of manufacturing reference geometry. Trimming and extending sheets and curves has been enhanced to provide more effective results with fewer commands, increasing efficiency. With new capabilities in the blend corner and fill surface commands, it's easier than ever to create high-quality surfaces that can be manufactured even in complex areas of your model, which was difficult to do in the past. Replace Face can now use a datum plane as a replacement face, and there have been improvements in multi-face and tangent replacement cases. Wrap and unwrap operations can be performed across multiple faces, including developable ruled surfaces. Points now supported along with curves and edges. 3D offset curve is a history feature for defining offset curves in parametric workflows to create high-quality shapes. Blend corner is a workflow function for creating a smooth surface in complex corner regions of native or imported parts. Fill Surface is a general surfacing function for creating high-quality surfaces to fill n-sided openings with G0 to G2 continuity and can use internal pass-through curves or fullness control. Part module improvements include the ability to easily move features into and between part modules, improved delete behavior, improved gesturing to activate, expand, and show part modules for fast editing, simplification of module update, and use of shared body where all the modifiable objects are emphasized. Sheet metal enhancements include improvements to bend taper to allow for positive or negative taper to be defined on any type of flange and improve creation workflow. Gusset improvements make them easier to define and manipulate in both the folded and flattened state. Additional alert messages provide complete information and status to the user. Flange on contour makes flanges definition easier and eliminates the need for timely workarounds. Improved flattening and convert to sheet metal functions now recognize and flatten additional conditions, including multiple joggles along a flange. Additions to the flexible printed circuit board design application allow specification of the target body for blends and show electrical components in the flat solid state. For data reuse, NX10 provides robust tools capable of supporting the complexities of real-world engineering challenges. It enables the efficient capture, packaging, and rapid consumption of a broad range of reusable design artifacts. The integrated creation of product templates allow you to fluidly move between model creation and template UI creation. This accelerates delivery of a variety of high-value content via fast and efficient libraries and searching tools. It provides a more comprehensive integration with the latest Teamcenter library technologies and eliminates the exit restart of NX and cumbersome external round trip to Java for creation of editing of product templates. NX product and manufacturing information and NX drafting have many customer-driven enhancements in NX 10. Many of these improvements are focused on giving you greater control over the display and placement of your annotation, both on drawing of the model itself. For instance, NX 10 provides a number of drawing format tools to assist in the creation and maintenance of the drawing templates. These tools include the title block command as well as the intelligent sheet zones. These commands have been enhanced in NX 10 to provide improved workflows. You can open a JT file and automatically create PMI information from it in NX 10. This includes dimensions, geometric dimensioning and tolerancing objects, weld symbols, centerlines, and much more. Since these are real PMI objects, they can be used downstream in a drawing or manufacturing processes like any other PMI object. With NX 10, you can take advantage of existing information much more quickly than before. Siemens PLM software recognizes the cost and effort associated with producing drawings, which is why with each release of NX they focus on delivering tools that support rapid drawing creation with reduced cost and increased productivity. Many customer-driven enhancements to dimension creation and editing have been incorporated into NX 10, as well as a number of annotation enhancements that provide improved compliance with drafting standards. These changes all contribute to simplified workflows and better productivity. Border and zone enhancements include greater control over the elements of a sheet border display. This includes line width and color controls, arrow display, triangular trimming marks, zones created from the center of a trim sheet, independent control over zone labels to skip, and additional standard-specific behaviors. Title block enhancements include automatic repositioning on sheet resize, being able to edit a table in a task environment, cut, copy, and paste support, better handle date attributes, word wrapping for support for cells, and user interface improvements. NX 10 also has support for vertical text and dimension enhancements for a single-sided display of linear and angular dimensions, support for associative linear directional dimensions and feature size dimensions, support for reusing existing ordinate origins, and support for adding jogs to linear dimensions and extension lines. Active Workspace is a powerful tool for finding information about your products quickly and easily. It is embedded directly in NX and can also be accessed in any web browser on any device including mobile devices. This makes it possible to quickly access Teamcenter software data from within NX or anywhere else. Active Workspace reduces the amount of time you spend searching for information with its powerful interactive search and filtering capabilities, which can access external systems, eliminating the need to search in multiple places. Because Active Workspace is context-aware, it only shows the information that is relative to the task being performed, which saves you time. By highlighting issues and visual reports, it helps you see the big picture so you can make smarter decisions more quickly. HD 3D capabilities. The NX issue briefcase allows design issues to be packaged from either within a Teamcenter managed environment or native NX, to be investigated and resolved outside the managed environment, for example, a supplier without Teamcenter. New server-side reports have been added for 4GD and visual reporting. There's a new visual report HTML browser and new out-of-the-box visual report for component pattern. Also, a new out-of-the-box checker and function has been added to Checkmate. This improves supplier collaboration and enhances browsing of reports and checks. NX-CAE is a modern simulation environment for modeling structural, thermal, flow, motion and multiphysics simulation, optimization, simulation data management, and simulation-driven design. NX 10 introduces new capabilities for one-way and two-way thermal structural coupling, fluid analysis, and acoustic and vibro-acoustic simulation. You also have access to the LMS Samcef solvers to simulate complex nonlinear phenomena and composites. Following slides highlight some of the key features available in NX-CAE 10, including a new multiphysics environment, adaptive meshing, and updated expressions, functions, and evaluation. The new multiphysics environment in NX 10 takes simulation integration to a new level to help you connect two or more solvers to streamline the process of performing complex multiphysics simulation. The Multiphysics environment delivers a consistent look and feel for performing multiphysics simulations, so you can easily build coupled solutions on the same mesh using common element types, properties, boundary conditions, and solver controls and options. This initial release of the Multiphysics environment provides the ability to solve thermomechanical problems in loosely or tightly coupled modes. Coupled thermostructural analysis leverages the new NX Nastran SOL401 multi-step nonlinear solver and a thermal solution from the NX thermal solver. Using NX10, you can now more easily tackle complex simulations such as blade clearance analysis within aircraft engine systems or structural analysis of automatic powertrain components within high temperature environments. Other applications for electronic components and metalworking processes are well suited for the multiphysics environment as well. NX10 introduces a new adaptive meshing capability for better solution convergence and solution accuracy of structural, thermal, and multiphysics solutions. Adaptive meshing automates the lengthy and repetitive process of running multiple finite element analysis with different mesh densities. The mesh refinement is determined by stress, strain, and temperature error estimates associated with element stress and strain discontinuities. Based on these error estimates, the software identifies critical regions in the model which become the target for further refinement of the mesh in subsequent iterations. Some simulation models require highly independent loads and boundary conditions, some of which are unknown until solve time. NX10 introduces new expression functions, quantities, and an evaluation system that simplify the task of defining these independent LBCs and can even evaluate expressions at solve time. Expressions can even reference proprietary user-defined code like thermal subroutines, which makes them much easier to manage and use. In addition, these new expression quantities and functions provide significant benefits in post-processing operations by leveraging relationships in the data that allow you to get a greater understanding of the model's physical behavior. For example, you can create user-defined expressions that combine simulation results as a function of time, which you can then plot out in NXCAM. Structure enhancements include LMS Samcef solver environment, extended composition simulation capabilities, and integrated vibro-acoustic analysis. NX10 introduces a new environment for the LMS Samcef solver, which offers a nonlinear finite element solver for structural analysis covering a wide range of applications in the aerospace, defense, and automotive industries. With the LMS Samcef solver, you can run linear and nonlinear static analysis as well as modal and buckling analysis. The solver includes unique capabilities for the prediction of complex nonlinear phenomena like progressive damage in the unidirectional and woven fabric piles of a laminated composite structure, as well as delamination with coupling to the damage inside piles. New capabilities in NX10 for simulation modeling and post-processing mean you can now perform an integrated end-to-end vibro-acoustic workflow to increase productivity for automotive NVH analysis. In NX10, you can easily create cavity mesh starting from just a structural finite element mesh of the outside of the structure. You can create load recipes to define loads from external sources such as measurement data. You can set up and run NX Nastran vibro-acoustic solution, which can include structural acoustic coupling, panels for contribution analysis, and absorbent panels. You can then post-process results for sound pressure levels and panel contributions. With the NX10 release, enhancements to the two-phase immiscible fluid simulation capabilities expand the types of applications you can evaluate. You can now simulate fluid flow problems for a mixture of any two immiscible fluid constituents, meaning you can specify two liquids or gases as long as the two fluids are immiscible. Additionally, you can simulate open volume enclosures, such as the filling or emptying of a tank, by specifying the track fluid area fraction of the mixture at the ambient condition. In NX10, it's possible to create a boundary layer mesh in the finite element model file with the NX Advanced Fluid Modeling module. Creating the boundary layer in FEM gives you greater control over boundary layer mesh because you can visualize it and use all the mesh controls and quality checks you normally would with any FE mesh. This also makes the boundary layer mesh available for other applications in addition to computational fluid dynamics, such as for acoustics applications. You can take advantage of the NX-CAA geometry and mesh processing speeds for use with extended CFD solvers by exporting the boundary layer mesh to the CFD general notation system file. Modeling enhancements include mesh wrapping for fluid domain and updated expression functions, quantities, and evaluation system. Analysis often need to start their simulations from legacy finite element mesh data, meaning no surface geometries available. This poses a difficult challenge for CFD analysts who need to create the fluid domain mesh for the cavity inside the part. NX10 introduces a new mesh wrapping capability that solves this problem by allowing you to generate fluid bodies from models for which you have mesh data but no geometry. The new expression capabilities highlighted earlier in the presentation can be applied to post-processing. These new expression quantities and functions provide significant benefits in post-processing operations by leveraging relationships in the data that allow you to develop a greater understanding of the model's physical behavior. For example, you can create user-defined expressions that combine simulation results as a function of time, which you can then plot out in NX-CAE. Result probe command lets you specify the geometry context, iterations, and a formula. The formula can be an expression of result-based quantities, non-result-based quantities, or a result expression. You can use a result probe to generate various post outputs such as contour plots, animation, graphing, a table field, and so on. There are many enhancements to increase your efficiency in NX10 for manufacturing. NX10 introduces a wide range of powerful features for computer-aided manufacturing, tool design, inspection programming, and production layout design. New industry-specific capabilities in NX10 help you program faster and machine better quality parts. The new roughing strategy enables you to achieve more consistent tool load, minimize tool wear, and extend tool life in NX. This capability is especially useful for more complex parts that require different cutting strategies for different regions. NX applies inward or outward cutting direction, finds the best available start location, and uses the right engagement type to enter the material. For certain types of molds and dies, the programming time can be significantly reduced. The enhanced rest machining capabilities offer better tool life and higher quality surface finish. The interactive cut region control functions have been extended to cover flow cut, the valley rest milling operation, and specify a range of cut patterns for steep, shallow, and flat areas. To ensure that the best cutting method is used for each area, you can preview, change, and reorder the regions before generating tool paths. You can quickly and reliably program even the most complex molds and dies. Automated feature grouping uses feature-based machining capabilities to identify, filter, and group similar holes. You can minimize the number of operations needed to machine parts with many holes. Holes sharing similar attributes are programmed together so that they share tools. On the shop floor, the optimized machining process can reduce tool changes, shorten travel distance, and increase drilling accuracy. The new chamfering operation applies the powerful hole milling approach to a common feature with a minimum programming input. NX10 enables you to automatically calculate the correct tool offset for chamfering holes. You can reduce programming and machining time by chamfering multiple holes with one operation, even when the holes have different orientations. And you can use a single tool to machine chamfers of different sizes that save you even more programming time. The in-process visualization displays uncut material after each operation. Exact alignment of the tool with blade geometry can be achieved with the enhanced swarfing in the NX Turbo Machinery milling module. Complex blades can be finished with a single pass using the entire length of the tool, which can produce a high-quality surface finish. The gradual engagement of the tool with the material ensures machining with reduced vibrations that further improve the surface quality. Flat, bullnose, and tapered end mills can be used to generate a swarfing toolpath that machines the entire blade with a single pass. You can quickly create 5-axis machining operations for large rotary parts, such as aircraft engine casings. Select a single edge and NX will generate all the necessary operations to machine cylindrical faces. For some rotary parts, this method can save you hours of geometry creation and model preparation. Also, 5-axis chamfering and deburring operations can easily be generated using this cutting strategy. The automatic inspection program capabilities in NX CMM10 lets you create accurate and safe inspection paths. The link to PMI function uses the solid model's product manufacturing information to automatically program measurements against a provided positioning and tolerance information. The programming automation of the link to PMI has been enhanced to provide scanning operations in addition to touch points. This greatly increases application opportunities for this powerful automation method because scanning measurements are being used more frequently. NX10 expands the automated collision avoidance methods to include movement of measurement points. For example, a touch point positioned too close to another surface will automatically be moved far enough to avoid any interference. NX-CMM can be used to analyze measured results by bringing them back into the graphics system to compare against the as-model geometry. In NX10, these measured results can be stored in the NX part file for further analysis. NX measurement tools can be used to display deviations and create annotations for reports. Subsequent measurements can be compared against previous measurements as manufacturing processes are refined and qualities improved over time. It's quicker and easier to find standard parts you need in NX10 because you can define a search and save it in the reuse library. You can even place a search directly in the NX ribbon bar for quick access. It is simpler to create parting surfaces with the new guided extension option. This lets you create an associative parting surface based on a set of connected curves or edges. With guided extension, you can create parting surfaces in areas where other methods cannot. You have more control over tool motion simulation than ever in NX. Kinematic models can be easily changed as control data. There is support for more cam types and lifters as well. You can also create user-defined motions such as linear movement along a vector or angular movement along an axis. With these options, you can validate your mold and die assemblies more quickly and accurately. NX10 also includes new production line design capabilities for automotive assembly manufacturing. The new Line Designer application enables engineers to design and visualize layouts of production lines in NX. The parametric capabilities in NX enables you to efficiently design manufacturing components and to easily accommodate any changes. When adjusting the size of the individual components or modifying the layout, the entire production line automatically updates. The fully classified equipment library is managed by using Team Center, a complete system for data and process management. The solution connectivity allows manufacturing engineers to connect to the library. By connecting to the Team Center library environment, you can utilize the powerful search, view, and retrieval capabilities across a fully classified library directly from NX. Siemens PLM software provides a unified platform for product, tool, and production system design. It supports the entire workflow, from product and line design to virtual commissioning. The layout designed with Line Designer can be used to validate the manufacturing process using Technomatic software for digital manufacturing. This concludes today's presentation. If you have any questions, please feel free to contact us. Our website is www.sisinc.org. Thank you.